Hello again, everyone. Today we are looking at how to calculate weight using Newton's second law. So remember that mass and weight are different things. Remember that mass is how much stuff your body is made out of, and weight is the force of gravity pulling down upon an object. Okay, so let's look at our worksheet today and see how to calculate weight. So for weight, you need to know the formula for weight. So weight equals mass times gravity. Weight equals mass times gravity is our formula for weight. Okay, so for this one, we can put multiply between the mass and the gravity. We can put divide between the weight and the gravity, and divide between the weight and the mass. So if we need to calculate mass or gravity, we know we're going to be dividing. Okay, so remember that weight is W. Weight is measured in newtons, represented by letter N. So if you notice from our previous formula, force equals mass times acceleration, the weight is a force. So weight is a force. Okay, the M is the mass, measured in kilograms, just like last time, represented by kg. And G is the acceleration due to Earth's gravity. So hopefully you remember what this is. It's 9.8 meters per second squared. Okay, so this is just like the A acceleration from our last set of practice problems. Okay? Okay, so working through part 2, we have an example here on how to calculate the weight of someone. So in our English language, we use the word weight incorrectly. We use the word mass and weight interchangeably, but really they're two separate things, okay? Because weight is the force of gravity pulling down on you. Okay, so example 2 says, Drayson has a mass of 29.5 kilograms. Calculate his weight on Earth where the gravity is 9.8 meters per second squared. So for these problems, it is very important to know where are we, because the gravity on different places can change. So if the gravity changes, this 9.8 number changes. So we have to be careful and make sure that we're calculating the weight properly based on the correct acceleration of gravity. Most of the time, if it doesn't say where you are, you can assume that it's on Earth, but just be careful and watch for that. Don't always use 9.8 because sometimes it could be different. Okay, so for this, we have 29.5 kilograms. Kilograms is our mass. And the gravity here is 9.8 because we're on Earth. And the weight is what we are looking for. Okay, so weight equals mass times gravity is our formula. Okay, so that same formula is going to be used for questions 4 and 5 on this worksheet. Okay, so the next one, we're going to show our work. So we're going to take these numbers and plug it in. So weight equals 29.5 times 9.8. We're going to take those numbers, plug them into our calculator. So 29.5 times 9.8 gives you 289.1. And what's the units for weight? Newtons. Because weight is a force. Okay, so try questions 4 and 5 just like that. Pause the video while you're working on that, and then you can move on to part 3. Okay, for part 3, we're finding acceleration. So if we go back to our math triangle, we see that acceleration is here. So if we're looking for acceleration, we're going to do force divided by mass. So for section 3, for all of these, acceleration equals force divided by the mass. Okay, that's our formula for part 3. Okay, so let's read example number 3. It says, find the acceleration of a 1.5 kilogram toy car that is pushed with 25 newtons of force across the floor. So we're looking for acceleration. We know that 1.5 kilograms is our mass, and 25 newtons is the force. Okay, so our formula here, A equals F over M. Now we're going to show our work. So take these numbers, plug it into our formula. So F is 25. Mass is 1.5. So we're going to take 25 and divide it by 1.5. So remember, when you do this, whatever's in the top goes in your calculator first. This line means to divide. Okay? So don't get confused. So we're putting 25 divided by sign, 1.5 equals, and you're going to get 16.6 repeating. So I'm going to round that up to 7. And what is the units for acceleration? So remember, acceleration is going to be meters per second squared. Okay. All right, that is how to calculate acceleration. So for part 3, questions 6, 7, 8, and 9 are all just like that. Okay, we'll pause the video, do those problems, and then come back and I will show you how to do part 4. All right, for part 4, we are finding the mass. So if we come back to our math triangle, when we're looking for mass, we're going to do force divided by acceleration. So for all of part 4, mass is going to be force divided by acceleration. So let's look at example number 4. A soccer ball is kicked with a force of 8.9 newtons at the goal with an acceleration of 21 meters per second. What is the mass of the soccer ball? So we have 8.9 newtons. Newtons is the F. We have 21 meters per second, which is the acceleration. And we're looking for the mass. Okay, so the formula, mass equals force divided by acceleration. So we're going to take our numbers, plug them into our formula. Oops. Okay, 8.9 divided by 21. Okay, so again, when we do this, whatever's in the top is going to go in your calculator first. And this line means to divide. Okay, so in my calculator, I'm going to push 8.9 divided by 21. So for this, I get 0.4238, blah, blah, blah. So I'm going to round it to 2 significant figures. So because the next number is a 3 is smaller than 5, so I'm going to round down and keep it at 4.2. The units for mass is kilograms. Okay, so questions 10, 11, and 12 are all going to use this same formula. So go ahead and work on those. I hope this has helped you figure out how to do calculations with Newton's second law. So good luck and have a great day.